All right, welcome everybody to the Sunday night call. One more week until competition, or I guess maybe 4 days until competition. It's for week one for a lot of us in Minnesota. That's in Duluth. So I look forward to seeing anyone else who's on the call who's going to be heading up there. Tonight's call is all about autonomous programming. Afomia Mesfin, who's our autonomous lead. It's a new role for the KnightKrawler this year. We have our programming captain, and now we have a student dedicated to autonomous, which ends up being almost half of all the code on the robot, oftentimes. So we decided to put Afomia in charge of our autonomous this year. And we're doing some things different this year, so which I'm sure Afomia will talk about. But the floor is yours. Go ahead, Afomia. Take it away.
Hi. Okay. Scott basically kind of introduced me right now, but my name is Afomia. I'm on team 2052 KnightKrawler. And especially in the last few weeks, I've talked to a lot of different teams about how they do their autos. And a lot of the questions that I've gotten have been about PathPlanner and how we're using PathPlanner, especially since we just started using it last year. And then talking with Scott, we also got a lot of questions about command composition and how we're getting our robot to actually perform all these tasks in auto. So I thought I would talk about that tonight. Let me share my screen. Can we see that?
Yes.
Okay. So just to summarize what I'm going to talk about in the presentation, first I'm going to talk about the changes in how we do autos, because in the last 3 years, we've had 3 different strategies with how we're implementing different apps and ways that we use it in code. And then we're going to talk about the PathPlanner GUI, because that's also something that we get a lot of questions about, how to use all of its new features, especially with the 2025 update. And then I'm going to talk about key auto classes, as in like what we use in our code to either interact with the PathPlanner GUI itself or just how we're doing autos this year. And then we're also going to talk about command composition, so things like sequential commands and parallel commands, and we'll have a few examples of those. And then we'll talk about how we actually create a new auto class. So these last 4 bullets will be a demonstration in actual code. And then PathPlanner GUI will also be a demo. And then our last point is choosing autos without deploying. This is a feature that we implement so that it's much easier for us as a drive team, and going down to play actual matches, it's easier for us to change our autos without having to deploy every time to the robot. That's something we'll talk about at the very end, though, once we have our auto. Okay, so first I wanted to talk about comparing autos within the last 3 years, at least for KnightKrawler. I was not on the team for 2023 Charged Up, but looking back at our code, we were not using PathPlanner. A lot of the points that we used or the way that we followed our autos is we had manual points, so we'd have to create a new pose 2D, like you can see here with our X and Y, and then our rotational value. And then we'd also use the WPIlib trajectory generator class to actually use our drivetrain and all the different elements of our robot to drive that pose between those 2 points. And we also had manual configuration. So you can see it's a bit cut off here, but we would implement our own max velocities, accelerations. So it was a lot more manual path generation. I think, again, I was not on the team during 2023, but this took longer than maybe autos that we make this year because of the measuring, and there's a lot more classes to keep track of. So then in comparison to 2020, the name did not change, but this is 2024 autos. So last year, we started using PathPlanner, which was my first year on the team, and I experimented a lot with PathPlanner initially in the beginning of the season. So in PathPlanner, you can create paths, which are between, it's kind of like the different chunks of an auto if you think about it. So going between like the reef and the station this year. And then you can also make autos, which is when you're stringing together all your paths. So we use PathPlanner for kind of everything in autos last year. So you can see here like where we're keeping track of our autos in this enum. For each auto, we're actually creating a new PathPlanner auto. So this is followed using the GUI, because PathPlanner is like a custom motion trajectory follower. and it would handle all that path following and all those points for you. And I'm going to demonstrate using the GUI, but it was a lot easier than measuring out each point because you can visualize where your robot is going to move. It had a pretty nice interface to drag and drop points instead of manually entering those points. And then transitioning to 2025, we're still using PathPlanner, but we're using PathPlanner now for the paths, again, to make it faster and easier to actually get those points and use the visualizing software. But instead of using PathPlanner autos, the auto implementation to string all the paths together and then add our custom commands, instead of doing that, we're actually following those paths with our own path followers in the code. So here you can see like hard code and auto class. I'll use this as an example later, but you can see we're using a follow path command method. And this is actually through Auto Builder. So in the second picture down on the left, this auto builder follow path is what Path Planner would already do if you were running the autos directly through Path Planner. So if we go back to 2024, you can see over here in this autos folder, see all the different paths that are strung together. So Path Planner would use that follow path method already to follow between those points. But now we're writing that manually in code in hard coded classes in our project. And there's a lot of reasons for that, and we'll go through some of those more throughout the rest of the presentation. But one of our biggest reasons was it's easier to implement more complex commands. So things that use vision, for example. Also, I'll show this more in the GUI, but yeah, in general, creating new commands, having parameters, complexity, it's also a good experience for programmers to actually write out these commands. In like teleop commands too, there's a lot of different strategies and methods that you'd have to use. So writing autos in line like this in hard code is kind of the best of both worlds because you get to use the visual like interface of Path Planner and follow those paths and make those paths in a much easier way than actually measuring everything out. But at the same time, programmers get more experience with command composition, which is useful in other areas as well. And you can implement more complex things into your autos. Okay, so now it's going to be the demo. I'm going to start off by just going through Path Planner. I did a roundtable, I believe, last year too, where I went through a lot of the GUI, but there has been a lot of updates, especially with the new 2025 version. So I'm just going to go through making some new paths and show like what we used more so last year, and then also what we're using this year for paths. So let me stop sharing my screen. I'm going to use Path Planner. Okay, can we see that? Can we see Path Planner right now? Okay. All right, give me a second. Okay, so when you open up Path Planner, I made a new branch of our project and I cleared our paths and autos just so that we can start over like you would if you started off with a new project. But when you open up Path Planner, so this is the name of our, can we see my mouse? Okay, that's good. So you can see up here, this is our project name. So right now we're creating autos within our Reefscape project. So when you open up Path Planner, you can see on the left, you have your paths and on the right, you have your autos. So again, your paths are like individual chunks of each auto. And then your autos is where you would string those paths together along with commands that you would interface in the actual GUI. So this path section is what has been continuous between last year and this year. Before we get into the paths, we can go here into your project browser and your settings. And this is where this kind of config and app settings was present last year, but there's a lot more details this year and you can customize your robot a lot more so that Path Planner follows your path to the constraints of your robot at a much more accurate degree than last year. So you can see over here things like robot mass, your bumper width and height, even your individual modules. This was not present last year, but you can add a lot more details about what kind of modules you're using. And when Path Planner generates the trajectories for you, it'll have a lot more knowledge about the constraints of your robot and what it can and can't do, where it'll make those paths much more accurate. You have module offsets. This is also kind of a fun feature, but you can add like shapes to your robot to show where your different mechanisms are so that when you're making a path, you make sure that each of those mechanisms is aligned accurately with the reef side. So here you can see that this is just an ovular shape right here in the front of the robot. So we said that this is our front. This is just easier when you're making a path so you know which side is the front of your robot, but you can add more. Like we could have your elevator scoring side, or if you have some mechanism that interacts with algae. Then if you go over to your app settings, so these constraints are your global constraints. So any path and auto that you make is by default going to follow these constraints. So your max velocity, acceleration, etc. But in each path, you can also add custom constraints. So if there's a certain path segment that you want to follow slower than you'd follow any other path, you can also add that too. Um, but we're kind of just going over this to show how PathPlanner allows you to customize a lot of things and makes it easy for you to access those customization tools. It's right here in settings, and you can add all these things throughout the season and change them as you change your robot. Yeah. Okay. Here, I'm just going to start making a new path. So we can call this one, maybe we're going to go from, or we'll change the name in a bit. But let's just go down this right side of tools that you have on PathPlanner when you're making new paths. So these waypoints, you can see right now you have your start and end point, but you can also add more in the middle. Like if I double tap, this is my end point now, and this is my middle point. So each of these points, you're able to manually change the X position and Y position. And if you think back to 2023 in the presentation earlier that I showed, so these would be the manual points that we were inputting. But the nice thing about this is if you drag this, it adjusts those points for you. So instead of measuring, you can kind of visualize where you're trying to go. So maybe we have our starting pose over here on the auto line, and adjust that for you. Changes your heading. You have access to these values if you wanted to implement them in other ways, maybe not through the PathPlanner GUI, but you know where those points are. Okay. You also have event markers. This was present last year too, but these events can mark maybe when you're running a command. So if my command, actually, let's have this be down here, start right. And then we're going to go to reef poll, maybe A, B, C, D, E. Align with that, assuming we're scoring out of the front of our robot. So this event marker, you could add one along your path. Maybe you say this is like score L, score L4. So this event marker, we're not using these currently in our auto classes as I showed earlier, but you are able to interact with where these event markers are along your path and use them as triggers. And you can call a command whenever you hit that event marker. But we are using other ways to implement commands. But that is a feature that I've seen other teams use. There's a lot of example projects up on the code by 3015 Ranger Robotics who made PathPlanner that shows how you can use this. That's a cool feature. You also have rotation targets. We were actually experimenting with this at week 0 yesterday, trying to get our robot to rotate to face the side of the reef more quickly, so that we can use our vision. So this is going to make sure that before you continue with the rest of your path, you're going to hit that target at the correct rotation, and then you'll continue following your path. This is a new feature, point towards zones. You can add where you're trying to point to. We move this over to maybe a reef side. Down. Okay, we're going to pretend that's right on the reef side, but basically this is going to, so you can see here, you highlight which chunk of the path that you want to be facing that point. And this is helpful for maybe if you have, like I was talking about earlier with an alignment command. So this would be pointing basically directly at the tag. So if you want your robot to have a greater chance or more time to see that equal tag in alignment, you can implement that as well. And all of these are kind of just examples of how useful the PathPlanner GUI interface is. It's a lot easier to understand what's all this code would be doing rather than writing it yourself. And it's easy to drag and drop and visualize how things are going to happen in real life. It's easier to look at. You also have ideal starting states, end states. So maybe your last path, you're not stopping. Like if you had a strafe by auto, maybe you're driving past the reef and scoring L1, but you're able to customize these paths so much and add so much detail while at the same time being easy to understand for anybody who's looking at the GUI. This is what I was talking about with the global constraints. So these are going to be the same as I showed earlier in settings, but you can also just do unlimited. So you can see here our time actually went down because I said unlimited, so it's not constraining our speeds. It goes fast as possible. But again, another feature to customize how your paths are actually running. Yeah, those are the most important chunks of the PathPlanner GUI, but we can fix this up. And then you can change your names. Something that we also do in KnightKrawler is we have a consistent naming strategy. So for this year, we're calling it either start left and start right. So this is our start path, so we'd want to call it start right. We're going to E. Oh, yes, that exists. We're going to call it start right E2. Okay. I'm going to make one more path so that when we create an auto here to demonstrate something, it'll make more sense that we're linking two different paths. We'll call it E2 and then right load for our right coral station. Oh, another feature that I didn't talk about actually that we do use, you have the ability to link waypoints. So this, for example, this start point that I'm at right here, when you're setting up your robot on the field, you want it to be easier for your drive team or anyone who's putting the robot down on the field to understand where they're supposed to put the robot. That's a lot easier if you have a consistent start point from left and right. So if you want to keep that consistent between your autos, you create a linked waypoint, and we can call this, oh, we have a lot of those already. We can say start right. And what this does is in any other auto that you create, if we have another auto where we're starting right, except maybe for that auto we're going to the side of the reef, if we use this link waypoint button and we search up the name of our waypoint, start right, it will move that point immediately to the correct rotation and orientation of that value or that position that you saved earlier. So this keeps it consistent between all your autos and it makes it a lot easier to keep track of all your points that you're going. And then we can also do that here for our size. We just call it E. So when we're making our next path that's going from this point E to load at the right coral station, we're going to want to use this endpoint E as our next start point. So again, I'm going to make a new path just to demonstrate for autos. So here we'd search up E. And you can see it moved the start point over there to the right orientation and rotation value. So you know that this is not going to cause your robot to jump or anything between those points. You can drag this guy over here. Assume you're loading out of the back of your robot like we are, and line it up with your coral station. Okay, and then we can also add this over here. I wonder if we already have one. Right load. We can call it right load. Okay, so that's how we've been creating paths throughout last season and this season. There is a lot more features you can interact with that maybe we don't utilize to their full ability, but that's how we've been making paths. Okay, just to demonstrate and to make a point about why we're doing autos the way that we're doing autos this year, I'm going to add those two paths here. Let's see, we have our, gotta go back. Start right E2. So this is how we did it last year. You would add your paths here, start right E2, and then add another path. Add another path, then we have our E2 right load. So you see here how autos we are able to string together the two paths that we just made. And at the same time, there's also a feature to add named commands. So these are what you're implementing in your code to perform some task. So maybe if we have a score L4 command here. But the problem is that for scoring, you are not able to implement any parameters. You're not able to implement or input any values here from the GUI. You just have a drop down. So I would need a new command for score L3 or score L2. And you can't really see what these commands are doing or make any last minute changes to these as you're creating the auto in the GUI. It constrains your flexibility and limits the kind of things that you can do with your auto. But at the same time, it is really easy to add these different commands. You can also do a wait, and then the command composition features like sequential and parallel that will run commands at the same time or run them in order. You're also able to do that here. So I can add following our path here, and then maybe I have a command that I'm doing at the same time. So this GUI interface is very flexible and allows you to do a lot of the same things that we're doing this year. But I believe that this year our new strategy provides us a lot more flexibility and complexity within our autos. I'm going to pause here for questions just because I went through the GUI. So if anybody has any questions regarding how we use this or how you can implement this in your own code. There's also a lot more feature that I maybe haven't talked about. You can visualize a lot more things here. Okay, if no one has any questions about that, then I'm going to start demonstrating through our code the strategy that we're using this year.
Hey, Fomi, I just have a question. Sure. Can you drill into this thing like you might open up in a like an iPhone or something?
Sorry, what do you mean drill into this?
I mean, make it so you can see the detail. What's exactly happening near the reef there, for example?
Oh, like zoom, like kind of zoom in,
kind of
get
zoom
more
in there.
close
Just
up
kinda
view.
curious. Yeah.
Yeah,
Oh, there you go.
you can go
Perfect.
like
Okay.
that.
Gotcha. Thanks.
Yeah, the GUI has a lot of different features. You can zoom in. You can also kind of see the other side of the field. Generally, they recommend, like here, if you swap, generally they recommend creating your autos on the blue side because the reflection tool, that's just how the reflection tool works. It'll reflect your autos from blue to red. But you can also see the whole field and zoom in.
Thanks.
Any other questions? Okay. Feel free to pause me anytime, but I'm going to switch to the actual code. Okay, can we see that? Can we see my screen still? Okay. Let me make this easier to look at. Okay. This is actually something that I was talking about with team. Oh, sorry, Scott.
Fonia, can you increase the font size at all? It might. I'm on a pretty big monitor, but not everybody is.
Let me close this. How's that?
It's better. Now, oh, that's
really
great.
see.
Oh, the last one was
This
pretty
is
good.
great.
Yeah,
okay.
I think that'll be easy to watch on just about any screen.
Okay. So right now I'm in our drivetrain subsystem, and for PathPlanner to work either with the method that we used last year with the paths and autos directly through the GUI, or how we're doing it this year to follow the paths, you need to configure your auto builder. You need it for PathPlanner to understand how it's supposed to apply the trajectories that you've created. So you saw in 2023 how we had the manual auto configurations and we passed in our drivetrain and everything. So basically you're using this for the GUI so it knows how to apply those custom trajectories that it's making for you. So what I was saying earlier is I was talking about this with team 7038 Pizza Pies. This autobuilder.configure, there's a lot of things that you need to pass in, but it also allows you to customize the way that PathPlanner is actually using your robot to drive those trajectories that you're looking at in the GUI. Sorry. So you gotta pass in a lot of things. For example, it needs to know where your pose is. It needs to be able to know how to reset your pose so that your odometry is accurate as you're driving your robot and when as your auto's running on your robot and when auto ends. This is the method that we're using to drive a robot this year. It's a lot more complicated than it looks last year, but this would basically be your drive method. You're also able to customize your PID constants for translation and rotation. This config feature earlier when in PathPlanner, when we went to settings and we looked at all the different things you can customize for your robot width, your module length, your uh, all the different configs that you had on your robot. Up here, you can see that we're getting those configs from the GUI settings. So right now, as we're using PathPlanner, all those configurations that you set up in the GUI are what is applied here when you're creating your method for which PathPlanner uses to drive your autos. But at the same time, if you wanted to manually write those configs out, perhaps in your constants class, you could do that too. But it's a bit easier to just input them within the GUI. So that's what this is. Um, this autobuilder.configure, if you are using PathPlanner at all, you will need it. There's a lot of examples of how to implement it for different types of drivetrains up on the source code for 3015 Ranger Robotics. So if you need help with that, they have a lot of different types of examples. But I just want to show how PathPlanner is actually driving your robot. This is where PathPlanner figures out whether or not it needs to flip your robot from blue to red. So just to touch back on what I was saying earlier about making all your autos on the blue side, and that PathPlanner will recognize if you are on the blue or red alliance and flip those paths accurately to red. Um, and while we're in our code, please tell me if I skip over something that has a particular name that our team uses that is maybe a custom name for some class that not all other teams use. That's not just like a WPI lib custom class. If I forget to explain what that is, so please stop me and ask. Okay, so now we're gonna go to Autobase. If you look over here on the folders, when you look at our auto folder over here, there's two sections. We have our common and our modes. Our modes are basically what the autos are, what autos we're running. But our common includes all the features that every single auto path will need to implement or use, and Autobase is one of them. Autobase is basically a blueprint for all the autos that we create. We store here the commands that autos need to run, all the different features that each auto would need to implement or have access to, like resetting our pose. And because each auto will extend Autobase, that's how it'll have access to all these different methods, and it can implement all its different commands. Okay, we're going to start off with just the constructor. And each of the autos that we create, we're going to need to use this constructor because this is an abstract class. It basically just acts as a blueprint. So every auto that you make, you're going to need to pass in the start pose of your path. I'll show how to do that later. But essentially what this segment of code is doing is it's checking if that start pose is even present. If it's not, it'll create a new empty pose 2D. This flipping util, this came, how do I say this? The thing about PathPlanner is when you're using the paths in line the way that we are this year, it will flip all the paths to the other side of the field, but sometimes the start pose gets a little messed up because of how it initially resets your odometry. So we had a problem with that while testing before week 0. Didn't seem to be flipping our field pose, our start pose to the other side of the field, so the robot was driving in the wrong direction to reach that start pose. But this flipping util is a PathPlanner class, so I believe that this is also present on the examples up on Ranger Robotics. There's a lot of different PathPlanner class that you can go through, but this is the method that we are using to make sure that our start pose starts on the right side of the field, depending on which alliance we're on. This set start pose, here you could just see where this is resetting our odometry here. So our drivetrain resetting our pose to the start pose that we pass in. this init method. So because this is an abstract class, any class that extends auto base, so a class that extends auto base would be an auto, for example, the one that we're about to make, would need to implement this init method. And this init is just what this auto is going to start doing as soon as the autonomous period starts. So it would include the paths that you're going to follow, the commands that you're going to follow in the right order. So we'll go over that as we make a new auto. So for example here, this is another feature that we implemented that kind of shows why it's useful to use the PathPlanner GUI at the same time as implementing it in actual code. We have a wait command feature, or no, a delay selected time feature, where you're able to make sure that when you're consulting your alliance partners and it seems that when you run your autos, you may kind of cross paths at some point and you want to avoid that by perhaps pausing your auto for a bit, we're able to input the amount of time that we want to wait before a path runs on dashboard. So this, we'll talk about auto factor later, but this get saved wait seconds, it's getting the value that you put on dashboard. So maybe you're inputting 3 seconds. So this will get that value, that double value 3.0, and it'll create a new wait command. So once you start your auto, it's just going to do nothing for however many seconds that you input. So this is more of a strategy thing that we're able to implement. And yes, you can use a wait command in just your auto in general in the GUI, as we saw earlier. But again, you're not able to get any parameters, especially not from dashboard. You're not able to change that between every auto and customize that without redeploying your code to your robot before every match. And maybe you're at the driver station already and you're talking with your alliance partners and you just realize that you need to change that. So instead of not running your auto at all, you're able to change that on dashboard and update that, and then you're able to pause your auto for the needed amount of time. So that's just an example of another feature that we're able to implement now that we're using this strategy for autos. Okay, this follow path command is arguably the most important method in this whole strategy. Instead of straight following through all our PathPlanner autos through the GUI and following each of your paths and your commands, this is how you're able to write your autos in line. So this will perform the same task that PathPlanner will already do to follow your path using all those custom configs and your drive methods, as we saw earlier in the auto builder when they configured it. But it's going to take your PathPlanner path, create a trajectory, and this follow path method is again going to use all those configs to actually follow that path, make sure your robot follows it accurately. Okay, so over here, I kind of made a bit of a framework to create some example commands that maybe we would be able to use in our autos inline. And here we can also start talking about some command composition, including parallel commands and sequential commands. So one of our commands that we're going to need is, holy moly, human player intake. So maybe we've just run a follow path command, and this path that we input here would be running from a reef side to the station to get a new coral piece to score. So we want to be able to use our intake mechanism and grab that coral. Oops, sorry, keyboard. Okay, so any of the commands that the methods that actually return commands that we're going to create in Autobase need to be protected. This just means that any of the classes that implement Autobase, which again is going to be all the autos, are able to use that, but no other classes are. So we're going to call it protected. And it needs to return a command because Autobase extends sequential command group, which is basically how you interact with the command scheduler to add different commands that you need to do in a certain order that you create. So when we add it to our auto class and it's going to make a new command, you can call it human player intake. So something that we would want to think about is for our intake command, there's a certain time where we would want to stop it, and there's also a certain time where we would want to cut it off, whether or not we have a coral, because your auto time is very limited. 15 seconds is not a lot. So you want to be able to implement maybe a check to see if you have a coral. So we can create a new parallel command group. I'm assuming we have a lot of programmers on this call. We've maybe had experience with parallel command groups and sequential command groups, but a parallel command group will run these different commands or actions at the same time. So they'll happen simultaneously. And there's different types of parallel command groups, but if you say just plain parallel command group, it's going to run until all of the commands that you've listed are done. They believe that they have finished, they're removed from the command scheduler. So you need to make sure that all the commands that you add under here will actually finish so that it doesn't go on forever. You also have parallel race groups, which will end as soon as any of the commands that you've listed over here have finished. So for this one, you just need to make sure that at least one of the actions that you're taking within here, one of the commands, will finish so that it cuts off the rest of the commands. You also have deadline groups. So maybe you want to cut off your command as soon as just one specific command is done. So maybe we want to be like, for example, if you had an alignment command, you'd perhaps want to cut off your alignment command as soon as your follow path is done. Regardless of whether or not the second command thinks that it's completed, you want to stop as soon as the first one is done. So you can implement that as well. For this one, I think we can do just a parallel command group. Give me a second. Actually, I've changed my mind. I have a better example for this parallel command group, but for this one, we're going to make a new instant command. An instant command is one that ends immediately. It doesn't check if there's no is finished method. Basically, it's going to be if you're changing one thing in your code quickly, and maybe some other subsystem will implement that. Like, for example, in this instant command, we're going to go to the hand command factory. That's what we have. Our hand is basically what is actually grabbing the coral for us. That's what our class is called. So we have this kind of just looks like a hand. That's why we call it a hand, but it's on a pivot and it has wheels at the end. It'll intake the coral. So we're going to start the motor for our hand. Just do motor in. Oh, wait. Why am I? Oh, okay. This is actually already a command. What did I do? You might have the wrong kind of guy. Give me a second. Okay, there we go. So now let's try this. No?
If only you need to put either a subsystem here, or I think you can do motor in.execute. But normally you would have a command run a subsystem, not run another command.
Right, yeah. We could do that. I just don't think we have the method for our motor in otherwise than in our hand command factory. Or other than an instant command, we can go back to our...
You don't need to make it an instant command. You just do the hand command factory.
Yeah, I got that. Okay. I'm actually gonna make this a sequential. Okay, we're going to add more to this command group, but basically this hand command factory is just running our motor in so that we can intake the coral. But perhaps what I was saying earlier is you can also add different checks for when you want to end the command. So maybe we're running this command until we have a coral. Method that we have is getting if we have a coral. So something you can use is .until. You're going to provide a Boolean supplier that's going to check whatever value you're inputting here, and it'll cut off the command as soon as that's true. So for example, Okay, here we can actually use the subsystem. Okay, so let's say you have your subsystem for interacting with the coral, and you have a method that checks if that subsystem actually has coral. We've changed how we do this now, but just for example, so you'd basically be running your motor in as soon until your hand believes that it has a coral, regardless of how you're checking that. And that'll cut off your command when you want it to. But at the same time, something that you'd want to think about is maybe that check isn't as accurate as you believe it is, or it takes too long to believe that it has a coral. So you might want to check off stop this command sooner than that, or within a certain time frame. So you can also use with deadline. You can see here, but basically what this is doing is as soon as whatever command you have in here is done, it'll cut off the command that it's attached to. So similar to the parallel deadline command group that I showed earlier. So maybe our command is a wait command. So this will make sure that we don't do anything within this deadline. We're just going to stop and wait and count the time. So perhaps we're putting in 1.5 seconds. So now what we've done is we have a method to run our intake until either we have a coral or it's already been 1.5 seconds and we just need to move on and continue with the rest of our paths. We have our safe brief alignment command. That was an example that I was going to create, but let's start with a more important method for this game, actually scoring our coral. And then we'll come back to this if we still have time. But again, you want to make a new protected method so that each of your autos can implement this method. And then you want to return a command. And we can call this one, we're going to go to position and score your auto. Okay, this is going to be specific to our team, but the way that we're controlling our elevator and our different mechanisms like the elevator and the actual arm and the hand is we're using this class called target actions. I'm just going to call this position. This target action includes information about the orientation of all our different mechanisms depending on what action we're trying to take. Like, for example, scoring L1 or scoring an algae or scoring L4, and it'll set up the rest of our subsystems, the rest of our mechanisms so that they're able to complete that task. So, okay, let me just show, for example, what some of those are. We have like L1, L1 high, L2, L3. So these are basically making sure that all our mechanisms are in the correct position to score. This one, we can make a new sequential command group. You could also break this up if you wanted to have just a to position to maybe get your elevator and your score in the right spot, and then a score method to actually run your outtake or however you're scoring your coral. But we're just going to do this together to show some different methods. Okay, so maybe the first thing that we want to do is make sure that our elevator and our elevator is in the right position. So for this one, I'm going to do actually an instant command because we need to interact with a subsystem and not another command. If you're passing in for an instant command, you have to pass in a runnable command, I believe it's called. And because subsystems don't do that, you just use this thing called a lambda. And then you're going to put in whatever action you're taking through your subsystem. It'll make it basically a nominal command. This is another team-specific thing. We have a superstructure subsystem that kind of interacts with this target action. Basically, this is just going to make sure that our elevator and our coral arm knows that they need to go to a certain position. Is it set for an action? Okay, this is taking in the target action or position that we're trying to go to. So like earlier, we said this can maybe be scoring L4. So maybe this auto scoring L4. So it's going to make sure that all those different elements and mechanisms are going to be ready to score on L4. Just using the right value. Do we know why this isn't working? Because I don't. Maybe I need just to do. What? Sorry, give me a second. I just not. Oh, okay. That's the exact same thing. Sometimes you just have to write it again. Something else that we can also think about is if we're going up to our position to score, maybe we want to stop our intake motor. Something that we changed in some of our autos is that when we're running back from the station to a reef side, we were continuing to run our intake so that we made sure that if the human player passed down the coral and the robot wasn't able to fully intake that coral, it would continue intaking on the path back so that it would make sure that that coral is properly adjusted to score. So perhaps you want to stop doing that once we get to the coral station or reef. So again, you're going to use a lambda because you need to pass in a runnable command, but the method is not a command. It's just a singular action. Stop. Is it going to do the same thing again? We're just going to keep typing. We're going to come back to that. And in this to position and score method that we created, we also had a wait until. I believe it was commands. All right, so looking back to our until here, we passed in some Boolean supplier value that would either return true or false, and if it returned true, we would cut off this command. So similarly here, we're passing in a Boolean supplier, but this wait until command essentially does absolutely nothing. It's just like a wait command, but it's creating a pause in your code until some condition is true. So whatever you're checking here will be what this wait until is continuously updating or continuously checking to see if it should move on to the next thing in your sequential command group. So this is basically letting us pause until something is true. For example here, something that we want to check before we score is if we're actually at the right position. I think I'm just going to try to do maybe the coral arm. So we'll see if our arm is actually at the right spot to score on whatever level whatever level we're trying to score. I think for us, you go through the subsystem. And again, this needs to be a supplier, but this is just one method that returns one value. So you'd use a lambda. Nope, it is at desired position. There we go. Only one. What? That's a Boolean. Oh, okay, there we go. So you probably want to check the elevator too, but just for the sake of time, I'm just going to check if the arm is in the right position. So basically here, again, your wait until is going to pause until whatever value you pass in is true. So far, we've said that our elevator and our arm subsystem need to be in the correct position to score. Then we've stopped the actual hand motor, so we're ready in a correct configuration to score. And then now we're just going to stop and wait until we know that we're at that correct position. Once we are there, another thing you can do instead of continuing to add to a sequential command group with this comma and then adding a new command, you can also do a dot and then it basically does the same thing, but it's something else that you can use, especially when you're trying to use maybe just one line of code. And then we started doing this yesterday. But maybe when you're up at the reef and you're trying to score your coral, once you stop intaking, perhaps the coral is at a different angle based on your mechanism. So maybe you'd want to intake for a few seconds. Can go to our, let me get it right this time, command factory. Let's see, we got our motor in. So maybe you're running your motor in, but at the same time, you don't want that to go forever. So maybe you're gonna go back and you do with timeout again. Let's say we're doing this for maybe just half a second. You're gonna intake for half a second, but then you also wanna make sure you stop your intake before you start outtaking. So we're gonna do kind of the same. Do we have a stop motor? Nope, we don't. So I'm gonna go back through the subsystem, but we're gonna need to use a lambda because again, you're going through a subsystem that's just one method instead of a command. There we go, stop motor. So now you're stopping your motor. Okay, and then last thing we'd want to do is obviously score our coral because now we're at the correct position. We know that because we've waited until we're at the correct position. We're gonna add another command to our list. We can go to the command factory. This is our method for scoring out, running our coral mechanism outwards to score. And again, you'd still want to put a timeout in this too, because something that you have to think about continuously throughout auto is how long each action is taking. So our timeout, and then let's say we're scoring for, again, half a second. For us, that would usually make sure we score our coral. Okay. This command is essentially using our, let's just go to reef alignment. This command is essentially using our vision to line up with one side of the reef. So you see the follow path command up here, but instead it would use whatever type of vision command that you have within your subsystem, or maybe an alignment command, and it would be able to get you up to that side of the reef rather than using your follow path. But I think I'm going to skip that for this presentation so that we can get to the other more important things. But again, that's another example of all the different things that you can implement the way that we're doing autos right now, using both the GUI for the different points and the trajectory generation, but then just writing code ourselves for the different commands that we want to create to also get more experience with click command composition. Okay. Oh, actually, another very important part of your auto base is to store your paths here. So this is going to be useful for easy access, like is written here. So when you're creating your actual auto files, you are able to implement these paths rather than rewriting them every single time. So for example, maybe we'll go to make a new PathPlanner path and call it, it was start right, and then we're going to go to E. So you're able to grab this PathPlanner path directly from the GUI. So this method that we made up here. So up here is essentially the same thing that we're going to do down here, but the point of this method is to have a check to make sure that path actually exists. It'll report an error, but essentially you just have to make sure that the name of your path in the GUI and the name of the path that you're writing here when you're doing your from path file is the exact same, so that it can grab the JSON file that PathPlanner generates and know what it's pointing to. So you can do that same thing here too. We're going to use the method that we have up here. Hello. Okay. And then in PathPlanner, I believe we called it SRE2. So we just have to match that up.
I have a question. Have you had issues with PathPlanner's GUI not saving paths between computers?
Yeah, actually, we have that happen at week 0 too. At home the night before, I had written a few more paths to test in the morning, but then when we moved over to our driver station laptop, it didn't carry over those paths from the commit, but they were still saved in like in GitHub desktop. The JSON file is still visible. Um, so I don't really know why that happens. If anybody has something to say
Yeah.
about that, but that's happened to us too.
Okay. Yeah, that was confusing me when one of our coders was like moving from one computer to the other, and I'm like, that is just not how Git has worked like the last decade or more, right? Like, so it was really confusing me until I actually saw it and it actually happened. So
Right. Yeah. I'm going to be honest. I don't know what the fix for that is. That's probably happened before, but yesterday was the first time that I really noticed it personally.
it's good to know that it's not just us and that we're doing something, wrong. So it's good to know that, we're not the only ones that are meeting that fate.
I remember encountering this last year when we were doing everything in PathPlanner, where we would make a change, run the auto. It did the exact same thing it did last time. We go in and open and close or switch tabs or something like that in PathPlanner, and then run the auto again, and then it would actually update correctly. So I don't know what's going on there with PathPlanner in terms of how it's deciding I have a change or a file to update or to write to the disk. But I don't think this is a new issue, although we never figured out root cause problem last year either.
Oh dear. Yeah, I agree. It's a strange problem that happens between different laptops, but I hope that other people aren't.
Our team's encountered it too. We've realized that like we'll pull in the change and then you have to like shut down the app and then reopen it again, and that'll work for us. I don't know if you've tried that, but normally it's just restarting the app and it'll work. So
We'll give that a try next time just to see, and we'll let you guys know if it's consistent.
Okay. Now that we've filled our auto base, which is basically our framework for all our new auto classes that we're going to create with methods for intaking and going to a position and scoring, and obviously our follow path command, we can go make an actual auto class. So I'm going to put it in mode. So like I said, for our file system, our common is the classes that each auto would interact with or are simultaneous through all the other classes. But for modes is our actual autos. Our naming system for our actual auto classes is we go auto, and then you're going to say which letter brief poll that you're scoring on, and then the number of what level. So for this one, maybe we're doing E4. And we can make a new path later, but let's just start with auto E4. So obviously your class needs to extend auto base, extends auto base, so that you can implement all those different methods that we created earlier. And then when you're making your constructor, if we go back to this constructor, you need to give it a start pose for your path so that it can adjust your odometry based on which side you're on. So the method that we've been using to do that right now is we just directly say our start path right here. So you can do just call this one start path. And now that we have our paths class, we actually don't need to remember whatever we called it in the GUI, because we can do paths dot this guy. Don't have this. Okay. And then whenever you're extending a class and you have your constructor of your child class, you can call the constructor of whatever class you're extending and pass in your start pose. So for example, for this, we do start path, and then PathPlanner has a lot of helpful methods, including getting your start pose. We're gonna do holonomic because swerve. Why is this guy mad? Okay. Okay. So you do need to have it be a static final path up here. The rest of them throughout your init method, let's get that in here actually. So going back to Autobase, because this is an abstract class, works as a framework, you have your init method. Every single auto class needs to define what that does for that specific class. Oopsie. Okay. This init method is going to contain all the different paths that you're going to follow and the commands that you're going to take for this particular auto. So you have access to all these methods within Autobase, but you're going to implement them obviously in different ways within each auto class. Something that we start our autos with is this delay selected time. So like I said, it's able to get a value from dashboard and use that number to wait for a certain amount of time that you'd like before autos start. So you're gonna do add commands. And this is because if we go back to Autobase, Autobase extends sequential command group. It is a sequential command, but represented as a class basically. And this is going to add a command to that list of sequential commands that you're going to run. So we're going to do delay selected. And then if we go back, you can see this is from Autobase. And this returns a command. So we don't need to do make a new command in line here. So obviously when you start, you're going to want to start by following your start path. So we're going to add another command. And you're going to do follow path command. Oopsie. And we're going to start off obviously with our start path. So, okay, so as we have it right now, this auto is going to wait whatever amount of time you've input on dashboard, and then it's just going to follow this path all the way up to our reef side. And then once you're at your reef side, you want to score. And we made this command earlier to position and score. So this is helpful because now over here in your actual auto class, you have a lot less to look at. You can do add commands to pose, to position and score. And then like I said, for us, we use this class called target action that basically describes where all our mechanisms need to be at for us to perform that task. Oh. And maybe you want to score L4, get all 7 points. So this is going to run all the way to our reef side and then score there where we're at. We also made another path that's going to run all the way to the station. So let's add that actually so that we can use our human player intake path. So we can call this one E, and then we're going to the right coral station. So we'll say right load. This is called. So again, you want to double check that these are actually the name that is in the GUI, because otherwise it'll be mad because it won't be able to get the information from PathPlanner about this path because it doesn't exist. Go back over here. Now that you've scored, I'm going to go back down to follow your path. You can go back to, so this is what I was saying earlier, but this start path is already here for us because we had to use it in the constructor to reset our odometry. But you can also just access any path that you have by calling the class that's in Autobase, this guy, and then the name of the path that you're trying to follow. So E to right load, and then we can do our human player intake. And again, this guy, we set it up so that it returns a command, returns a sequential command actually. So we can add that right in here because our add commands is just another command that we're adding to the list of this sequential command. I'll pause here for any questions if somebody has something to suggest for this or anything that you want to talk about regarding the class, what you can add here, why you have to do something a certain way.
If only can, and I hope you know what I mean when I ask this. Can you share why this is easier to test than building your entire auto in PathPlanner? So, for example, maybe I'll just say it. If you're a person like me and you're standing behind your programmers and saying, let's just make sure that we can drive up to reef to begin with. Just do that part. Now drive up to the reef. Now raise the elevator and put the arm to the correct position and just stop right there. If you're doing that in PathPlanner, you basically have to tear apart the auto that you built and delete out, hit the little trash can icon and delete out all the secondary steps to do just that drive to the first path. And then you have to start rebuilding your auto to say, okay, now raise my elevator to L4 and get my arm in the position to shoot the coral out. And so that kind of stinks because you have your programmers build all these fancy autos, but they've not run them yet. And now you sort of have to delete all the parts and then add them back in one at a time. Where what do we do, Aphomia, here when we just want to run the first path?
Yeah, so we actually did this a few days ago when we were testing, but you just have to comment out whatever commands that you don't want to run during your first trial run. So if I do this, then the only things that we're going to do when we run this auto is we're just going to follow this path. So now you can test each individual segment. Something that one of our members actually asked earlier in the season when I was talking with her about how we do autos this year is she was saying that the PathPlanner GUI is actually easier to look at than just the code, and she was wondering how this makes it easier to understand or look through. But I think part of the answer to that is this auto base. So when we're making our auto, we're not looking at all this timing and the strategizing that's needed to make these commands that you need to figure out the timing for and retest how accurate they are. So this is stored between a name, human player intake. All this can be stored within our to position and score. You're essentially doing the same thing that you would do in the GUI of doing things behind the scenes and then presenting a more visually appealing front when you're testing your autos. So it still gives you the ability to interact with all these different functionalities that are just provided through WPILib while still having something easy to look at. But then at the same time, you're also using PathPlanner for paths, which is much easier than measuring out those different points. So again, I feel like the strategy is kind of the best of all worlds. Okay, if we bring this back, I think the last thing that I was going to talk about is our auto factory. So in the presentation on the last bullet point of our presentation, I said how we're able to change our autos on dashboard without redeploying every single time. So actually the first spot I'm going to go in this common folder of all the classes that are, we'd use throughout each auto or in general for autonomous. You have your auto base and then you have your auto factory. I'm going to start off down here, actually, trying to make this bigger. There we go. So this enum for auto is going to store all your auto classes that you've just created. So all of this here, this is your technically constructor for whatever enum value that you're creating, and you're going to link the class that you just made. So this does look kind of complicated, but all you're doing is you're listing the auto that you've just created. So maybe let's name this one the same thing. You could do auto E4 load, because now we've loaded. And then you're going to link whatever class you just made. Again, this is a sequential command group. So you're listing all the different actions that your auto is going to take. So you want access to that information, E4. And then you just need to get the class because that's what we're passing in here. So this enum is storing all the autos that you've created, each of the classes. If you made another auto, you'd link it here. So now we're going to take a little pause from auto factory and we're going to go to dashboard. Where are you? Here. All right, our dashboard class is where we're pushing all the different values that we want to interact with on Shuffleboard, which is what we use as our display for all the different network tables values. You also have, I think this year news, clips, just smart dashboard in general. There's a lot of different things, but it's useful to display data. We're going to go here. So this is your auto chooser. I believe this is from Littleton Robotics. Basically, this is just managing the choosers that you're sending to Smart Dashboard. So this chooser is going to have different auto values, and then it's going to be called auto mode. So then let's go down to how we actually use this. When you make a new dashboard class, so you can see a lot of different teams have different implementations of dashboard, choosing different values and all the different things that they want to be able to interact with, maybe at the driver's station. So you're going to add a default option, which is just saying what you're going to do when you have no auto chosen, or if you forgot to pick something. Obviously, you wouldn't want to move, or you wouldn't want to do anything if you haven't chosen one. So you see how this no auto class is not linking to any class. It won't perform any tasks. Or maybe you have a different default auto. Maybe you have just an auto that drives forward. Oopsie. Back to dashboard. So then you're also going to go through each of your auto values. So that enum that we looked at earlier in Auto Factory that has your auto values, this is going to go through and push all of those to the same chooser on dashboard. So now you have all these options. The name is going to show up the same way that you put the name in this enum. So it would show up as no auto. Then you have auto E4 load. And then on dashboard, I don't have that on this laptop right now, but it'll just basically show up as a drop down, and you'll be able to choose as you set up your laptop and the driver station, whichever auto that you want to run. And then finally, in your dashboard class, you have this method that gets the auto. So you grab this auto, and this is important that you realize that this is just getting the auto that you've chosen on dashboard. So it's going to return. So this auto class, again, is this enum over here. It's going to return whatever you've chosen on the dashboard, whichever option. Go back to Auto Factory. Oops. Okay, so when you are deploying through PathPlanner, this was more true last year, but when you're deploying your paths, sometimes your old autos don't get cleared. So instead of running the auto that you've changed at that moment, it'll run the last auto. So you need to recheck. So that's why we used that last year. But then this year, well, also, okay, it rechecks if you're just pushing PathPlanner autos to your robot, like for example, driving them directly through the GUI. But at the same time, if you go down to robot container where you're getting your autonomous command, right now we're able to get this value from Auto Factory, but we'll talk about that later. But let's say you're doing, you can return a PathPlanner auto and just the name of your auto here. But the thing is, if you're doing this and you're running autos directly through the GUI, every single time that you want to change your auto, you're going to need to change this line of code and redeploy. You're going to have to add a new name here. And you can't just do what we were doing right now with just choosing an auto name off dashboard and running that particular auto. So that's what we use Auto Factory for. So the two important methods here that we're going to talk about is checking if we need a recompile, if we need to make sure that the auto that we've chosen on dashboard is actually the auto that is compiled and ready to run once we start the autonomous period. So this current auto is updated. The current auto is storing what you're going to run once you start autonomous. So I think that's the easiest way to think about it. And then your auto supplier, again, if we go back to dashboard, this is just getting whatever auto you've chosen from dashboard. So this is what you've picked maybe at your driver station, but this is what is actually going to happen once you start your auto. We're checking if these things are not the same, then you need to recompile your auto and make sure that what you're going to run when autonomous starts is the same as what you've chosen on dashboard. We also have this extra segment. This is just checking your wait seconds to make sure that the wait seconds that you've chosen on dashboard, again, is the same as the wait seconds that you're about to run. So this is just checking to make sure that when you start auto, what you expect is going to happen is what's going to happen. And this is actually, we'll go back to where this is implemented, but just remember that your recompile needed is checking to make sure if you need to, again, recompile to make sure that what's expected to happen during autonomous is what's going to happen. Your recompile, the updating wait seconds and update auto essentially does the same thing, but I'm going to talk more about auto because that's more consistent throughout other teams. So this is just your value on dashboard. I believe this shows up as green or red to show if we need to change our auto value. So again, we're going to set our current auto to whatever we have selected on the supplier on dashboard. I mean, if we haven't chosen anything, if we haven't chosen any value and the dashboard chooser is just empty, then we're going to call it no auto. Just going to use no auto. And your compiled auto is what's actually going to run. So either you've gotten a no auto or you've picked a specific auto from dashboard. So you're going to get what that auto is, and you're going to set your compiled auto, again, what's going to run to the auto that you've chosen. If this is still no, I don't think we're really going to talk about this, but this is basically just your value that is pushed to dashboard to show what your auto is going to do, just a string. So you're just going to say that you haven't chosen an auto. When the autonomous period starts, you're not going to run anything, but you don't need that. It's just going to do nothing if you have no compiled auto. And if your compiled auto does exist, which means the auto that you've chosen on dashboard exists and it's a full class like we've created earlier with all your commands that you're going to run, it'll start that class. Call init. And again, this is the class that's in AutoBase that is implemented and does something different in each of the autos that you create. So for example, in this auto, our init method follows the command or the auto that we want to run once this class is called. So now your auto that you've chosen on dashboard, autosupplier.get, is the same as the compiled auto that you're going to run once autonomous period starts. So now we're going to show where these commands are actually run. If you go to, I believe robot. Yep, okay. So in your robot.java, you have your disabled periodic. So this method is always running throughout the time that you're disabled. So this includes when your robot is set up on the field before starting a match during autonomous. And you're going to use robot container to pre-compile and auto. So this is the method, or actually just gonna go in. So we just went over what recompile needed does, but it makes sure that your selected auto is the same as the auto that's going to run. And this will return true if those are not the same and we need to recompile. If they aren't the same, then again, we're gonna run a recompile to keep that consistent. So because of this, when you press the enable, or not when you press, during a match, you're not going to press enabling, but when your autonomous period starts, you're going to run whatever auto that you've chosen on dashboard rather than having to redeploy through this get autonomous command, because this is just going to get your compiled auto. And remember up here in our recompile method that is called, if we have changed the auto value that's chosen on dashboard, then we're going to set this compiled auto to the correct value. Yeah.
Afomia, you may not even know this because we've been doing this auto chooser now for several years, but do you know why we do this during disabled and not just on auto init?
So it does it before you start your auto? It's already prepared in the background before you set up?
That's the biggest thing, auto prepared in the background. So that init that you run is going to hit the file system and load a file and parse through that JSON file for every path that we're doing. And that's not fast. The first year, and it might have been 2018 when we had our paths stored in files, we would basically build the auto on auto init based on what was in the drop-down list on Smart Dashboard. And our autos were taking a full second and a half before the robot would start moving. And what we figured out was it's all that time to load all that the file off the disk and to parse through the JSON and put together what you were going to do. And so now, and KnightKrawler has now used this for many years, which is why Afomia wasn't familiar with this. We have this process where we're constantly checking, have I already loaded an instance of the class for the auto that we want? And if you change that dropdown, you have to identify that there was a change and then reload the instance for the other class, the new class that you've selected. So that's an important tip, I think, for anyone out here who might be looking at this and saying, this is a lot of wasted stuff. Why are you doing this in disabled every 10 milliseconds? Why not just do this in auto init? It's because you're hitting the file system to load those paths. So it's a good idea to already have your instance of your auto ready to go as soon as auto init starts running.
Right, yeah. It's ready to go, and then at the same time, it's much easier to change rather than deploying. Yeah, sorry I didn't say that explicitly. Like you said, all the time that I've been on the team, we've always done that in the background. I haven't experienced like the time it takes if you don't do that in the background at the beginning of an auto to read through those files. But you're right, that is another big reason that you don't want to use this. I opened this up while you were talking, but just as an example for the JSON file that it has to read through and grab all the values from to generate the trajectory. So this is the path that we just made. You can see how it's storing all the information like the waypoints, any constraint zones that you've added, your end state. So you're right, that does take a lot of time to go through.
And in 2018, we didn't have computers that had SSDs in them. So hard disks were a lot slower. So maybe this wouldn't take a second to do. Still a good practice.
Okay, that was a long period of talking. I think we're going to pause now for any questions about anything that I've talked throughout the presentation, or particularly this part about recompiling our autos, doing that in the background so that we save time and are able to change them really quickly at the driver station. Or about, again, anything before, like the GUI or our experiences with it.
Fomia, let's say that I'm a rookie team and all I want to do is just move off the line. Can you give us a sample code for what it would take to drive off the line?
Oh yeah, that was something I was going to talk about. So for us, we just called that our dead reckoning auto. But essentially, the drive command that you're using to drive your auto, like during teleop, you would want to, let me make an example of this off here. So maybe PathPlanner isn't working, or you basically just want to run your drivetrain forward for a set amount of time. You would get, let me figure out what ours is called. Okay, so the command that we're using to drive is our default drive command. This is a little bit hard to demonstrate because everybody's going to have different names, different parameters for things, different implementations. But what you'd want to do in your get autonomous command method is you want to return that command that you're using to drive, but you're going to supply, so these suppliers would be what you're using with your joysticks. So the values that you're getting from your joystick for X, Y, and rotation. But obviously in autonomous, you just want to pass in a singular value. So we can do, because it's a supplier, you're going to do lambda X value. You just want to go forward. Let me just fill this out first and I'll talk about it. Oh, duh. Okay, so essentially, rather than reading joystick input, it's just going to read manual input of some value. So this might be a bit fast if yours is scaling relative to what joystick value you're getting. But I'll try to say this as generally as possible for different teams. You're going to use the command that you're using to drive during teleop, but instead of reading joystick inputs for this X, Y, and rotation, you're just going to pass in manual values. So I wouldn't want to move left or right, or probably rotate. If you're using a dead reckoning auto, then you probably just want to drive off the line for that auto ranking point. So you're going to pass in whatever value you need for driving forward for a set speed. But you probably don't want to be doing this for the entire autonomous period if you're just trying to get off the line. So this is going to require some testing to see what speeds work the best. But then you can also do a timeout so that you stop after a certain amount of time. Again, this is going to require some testing to get the timing right, but maybe it's 2 seconds. And you're going to run this command to drive forward for 2 seconds. So this is pretty quick and easy to change, but you would have to redeploy this because you're just going to change it as an emergency.
Would it be worth their adding that in to your choosable drop down? Just as a like at the end or something, so that it's already in there and you don't have to worry about like changing it on the fly.
Right. Yeah. So maybe if it's just your PathPlanner implementation, that isn't working. You could add, but then if you made a new auto class, you would need to pass in some start pose, but it wouldn't really matter. You could just pass in an arbitrary start pose, and then that's a good point. Then you could go to your auto factory and maybe add like a dead reckoning or just like a straight auto. What would you call this? Safety straight auto. Let me call this backup. So then you'd add whatever class would have that command linked into it rather than changing it and having to redeploy in your robot container. That's a good point.
And if you're a team with a kitbot, you could also go to your very simple autonomous that just drives forward. You could drive forward for 13 seconds at a very slow rate, maybe like 5% or 10%, whatever it takes just to make your wheels move. So you can get across that, I don't even know what it is, 6 feet, 8 feet. And then you do maybe a 12 or a 13-second timeout, which leaves you 2 to 3 seconds left. And then just run your, whatever that thing is called at the end that just spits out the coral into L1. And so even if you're a rookie team with a kitbot or any team with a kitbot, you can have an auto that not only leaves the line, but scores, because you, in order to get that ranking point, don't you also have to score at least one coral for the alliance? So you could make your robot drive, and even if it reaches the reef in, let's say, 8 seconds, if you're driving at such a low speed, you're not going to burn up your motors, and you're also probably not going to burn a hole in the carpet because you're running at only 5 or 10% power. Just drive up to that reef, just kind of keep pushing into that reef at really low power, and then after 12 seconds, start running your motors to just kick that coral out into L1. So very simple stuff to do, because you have something attached to your button, right? You push a button and that intake runs. Whatever that is that's probably a command, unless you're doing a pure looping or iterative or whatever that's called now, whatever it used to be called. The old way of building robot code where you don't use command based, you still have something attached to that button that will run that outtake motors, and you could just string that together right here with this default drive command and then and then, isn't that right, Afomia? Isn't it an and then that you would do after your timeout in order to run the outtake?
Right, yeah. You wouldn't even have to just drive forward. That's a good point. You could do a lot more. Like what you said, scoring, just dumping in L1 for the ranking point, and then also adding to your alliance's total autonomous score. You could start in the middle. Yeah, I think for us, actually, if we had a dead reckoning auto, it would be starting in the middle, running this, and then running our scoring to L1.
Yeah. Yep. So even for new teams, don't be afraid of autos. This is a good start that Afomia has put together here, and you can basically fake joystick input in order to make your robot drive forward at a low rate. Right now, she's driving forward at 30% power. Even that's probably faster than you would need to go. Just drive straight forward, and you'll eventually run into the reef. Maybe you'll stall your motors. Maybe the wheels will slip on the carpet, but at a low power, that won't be much of a problem. And then just before you run out of time, before your 15 seconds are up, then you can start the output motor.
I have 2 questions, I think. I see that you have like little grayed out text next to your code. I assume that's a VS Code extension, and I'm kind of curious what it's called.
Yeah, it is. I kind of forgot the name because I've had it for so long, but I'll look back. Actually, Caleb's probably on the call. He has the name memorized, probably.
Yeah, it's GitLens.
GitLens, I think. There you go. Okay, I remembered it. But yeah, it is helpful for seeing.
But maybe you should describe what GetLens does, because you didn't say what it does.
Oh, sorry. Well, you can kind of see over here when it pops up, but when you go over a line of code, one of the features is it shows when the commit was made for whatever time that line of code was added or edited, and you can see the commit message too. I don't really know if there's other key features. That's the main one that I've been looking at or using.
I think you can actually also go straight to the commit in GitHub too, if I remember right. I can't
Like
remember
that?
the right click. Yeah, connect to GitHub, and then I think there's a link to it that you can go straight into to see history and blame and all that other fun stuff.
Yeah, you can see the ID there on the left. That's CA95. That's the commit ID. So that makes sense.
You said it's GetLens.
Oh, Caleb just posted a link.
Yeah, it's linked.
Yeah.
And for PathPlanner, we used it last year and had a pretty good time with it, just because we implemented it just before we went to Houston. But this year when we tried it, we had a really hard time because it kept like jittering. Then we tried updating our PIDs and stuff, and then it like got better. But then like we passed the number by just a little bit, and then it got worse somehow. We're wondering if did you guys either have that problem, or did you guys just not use PathPlanner directly this year, and that didn't cause the problem?
Well, we're still using the path following and the trajectories generated by PathPlanner this year, just not the autos. We haven't really experienced that this year, but I have talked a lot to Team 7038 Pizza Pies. I think their programming captain Riha is on this call right now, but they've been working a lot with PathPlanner and getting their like PID values and their constraints to work for how their autos are running. She could probably talk more about that than me, actually. Is she on the call still? Probably not. But that's just to say that other teams have also been experiencing that. The first thing I was going to say is experimenting with PID values, but if you've tested with that, I wouldn't know what else you would test. Think.
I mean, we moved.
Well,
back,
does it look like?
we moved back to we were using personal splines and stuff that were made by our seniors a couple years ago, so we moved back to that. So we're actually getting kind of far with that. But I was just wondering if you guys were having that issue with PathPlanner too.
Oh, okay, that's cool. So kind of like 2023, I was talking about earlier, the trajectories and everything.
Kind
All
of.
right. Well. Yeah, we haven't personally had a lot of problems with that, but I know that other teams have, so you're not alone. I know I can't speak to those problems and their solutions as much, but there's definitely other teams that are experiencing the same thing. But I'm glad you guys found a solution through your custom source code. Oopsie. Does anyone else have any questions or stories to share about their auto experiences? Or teams that are new to PathPlanner this year?
Having observed our team do autos for a very long time now, what I like about this system, and I'm sure we'll probably adapt the system next year, and we'll find new and better ways to do autos because we're constantly trying to do those types of improvements, is that last year when we went to pure PathPlanner, I was frustrated watching students try to test our autos because we were constantly tearing apart the autos and then needing to remember how to rebuild them because we wanted to do the first path, now pick up, now do the next path, now shoot. And it was frustrating to test because it was difficult to test a piece at a time. This year, we have Afomia and Caleb have built a system where we drive to the reef, but as soon as the robot's able to see the tag on the reef, vision takes over and it ignores the rest of the path. And we were having problems getting lined up. And I said, just go in and comment out the vision part and then see where it goes. If it does the same thing, then we know the camera's not even able to pick up the tag. that would have been a really difficult thing to do with purely PathPlanner, because you can't just pull out a piece of an auto and let the other stuff run. So I like that we're back in code now, because I feel like it gives us more control to diagnose problems. It gives us more control to break down the issues and insert a little bit more kind of debugging concepts into what we're doing. Even just adding an instant command that just dumps out system.out and gives you an idea of, did I even get to this spot in the auto, or did it get completely skipped because the deadline fired before my thing was supposed to run? Those are things that, a lot of those things you can do with PathPlanner. It just seems a lot easier when you can just type it in and throw in the code and then comment it out, because you don't need it right now, but you might need it again. Where with PathPlanner, it's either in or it's out. And if it's out, then you got to rebuild it or recreate it or reinsert it later. So that's what I like the most about this system. It is more complicated. With more control comes more complexity. But I think the control is worth it.
I have the same feeling with Blockly and helping in the fall, where you have to like move the little blocks in, and it takes like 20 minutes just to make a basic, if statement. But then in code, you can do that in like 3 lines, right? Like, and there's no good way to like remove a section of Blockly without like pulling a whole section out and then slowly putting it back.
I will admit that almost all this code that Afomia showed tonight is the first time I've seen it, because I've been spending most of my season on the build team this year. I think, having looked at what they've put into the auto base class, I feel like by coding the autos, it also is encouraging the students to think more about reusability, where previously last year we may have strung the exact same 3 commands together over and over and over again in every auto that we did. And now they're thinking about that, saying, look, I don't want to type the same thing over and over. And they're putting things into auto base, which is a great skill for a programmer to have. Afomia alluded to it earlier of, this just makes you a better programmer, but she really didn't say why. I think the idea of realizing that, oh, this is pretty common, we could just throw this into the base class and then all the autos could use it. I think that's putting a very fine point on the fact of, this is how it makes you a better programmer.
Yeah. And then at the same time, having easy implementation, but then also the parameters is actually a really big thing, because like last year for this 2 position and score, you would essentially have to make like 5 of these just to do the same thing with different positions. And then in PathPlanner, you would have to add a new command that would run whatever this is linked to and named commands. And then now you have a really long file with all these different commands with every single possible way that you could implement them. But it's much easier at the same time to, maybe in your auto, to figure out what this is doing. Just go into auto base and you can edit it really quickly, rather than fidgeting with the GUI in PathPlanner.
All right, we're significantly over time. Any final thoughts by anyone here?
Scott, I had one question. This might be a little more directed towards you. I heard you pitching in kind of about the code and stuff tonight, and you were talking about how you're kind of more on the build side of things. Did you learn stuff more on your time, or did you get interaction between you and the students to understand what the code's doing?
For this year's code?
Yeah.
Well, I looked at most of it for the first time tonight. I'm a software developer in my real life. This year, I have spent a lot of time on build, mostly in the CAD group. I've been a CAD mentor now for the last couple of years. And then once the robot's built, I sort of shift gears and I go back to code. I used to be primarily a code mentor on the team. And then once we got heavy into CAD, I kind of switched over there. So now for the next 2 days, I will be spending all my time with Afomia and Caleb to test autos. And then after, we're competing in Duluth. And then after Duluth, I'm sure we'll be fine tuning a lot of our code based on what we learned in Duluth. And I'll be spending most of my time as a mentor, as a programming mentor for the rest of the season now, I think. Does that answer your question?
Yeah, because one of our struggles is like most of our coaches and mentors are like mechanical, CAD, and electrical. So it's like they don't understand what's going on inside the code, and when they tell us to do something, it's like, well, it doesn't exactly work like that. So it's like, how can we get it?
Yeah, that's hard. That's hard. For a lot of people are scared of code. And that has nothing to do with just robotics. That's just in general. I'm an entrepreneur. I talk to a lot of entrepreneurs. I've talked to a lot of technical startup founders that were building a coding startup, but they didn't code themselves. And it's very difficult to convince people to say, hey, take a shot at this and try to learn some code, because for some reason it's just scary. It's okay. Code's not for everybody. But it is a tricky thing to do, and it is hard to communicate systems. And sometimes I have to jump in and help our programming students communicate with the either build students or build mentors when they want to do something, and our programmers are struggling to explain, why is this so hard? It's not easy. I don't have a great answer for you. My best advice is see if you can encourage some of your adults to learn how to code. I mean, if the kids do it, I think adults, somebody should be willing to take a shot at it too. Like I had to learn CAD. I had to figure out how to learn CAD in order to go help our CAD students. But it's hard. It's not an overnight thing, and there's no silver bullet. I don't know that advice was very helpful.
No, it definitely is. I mean, it's definitely not something that I could have just sat down and looked at one day and understood everything. So.
Oh, I know this stuff because we've been doing this command-based type programming now for quite some time, and we were doing it when I was a programming mentor. But I will say that Caleb and Afomia have done things this year that I had never even considered or hadn't seen before. So I do feel like I'm playing catch up, and I got to do my homework now in order to support them in the coming weeks.
Yeah, we've been using command-based for 3 years now, so it is starting to make a little bit more sense. But right off the bat, it was a little difficult because, I mean, I know you came out to help us. We're Team 2472, and you came out and helped us last year with PathPlanner for a little while. So,
yeah, command-based kind of flips iterative or loop programming, robot programming on its head. It does take a bit of time to get your head around it. That's for sure. All right. Great question, though, Ben. I really appreciate it. And by the way, call us again if you want us to come out. Afomia has been very helpful to other teams, and whenever we're not building our own robot or coding our own robot, I'm sure we'd be willing to come out and help. Caleb as well. Caleb's helped a ton of teams this year on their Swerve drives. Any other questions, comments? All right. Thank you very much, Afomia. Big round of applause for Afomia here. Amazing presentation. For those watching online, Afomia is accepting scholarship offers and job offers, so send them all her way. She's only a junior, so we have her for one more year at least. But excellent presentation. Thank you. And good questions, everyone. I hope to see you all next week. Next week, I've forgotten again already. Whereas one of our students is leading a conversation about what did we learn at week 1. And so next week, we're going to be talking all about game strategy that we observed, challenges we observed. We're going to do a full review of week 1 of competition. And I really look forward to that conversation. Also, we have a battery, how to maintain your batteries correctly the following week. And then after that, the schedule's open. So if anyone is interested in giving a presentation, please consider doing so. All right. Thanks, everyone.
Thank you very much. Good luck next week.